his book on the Bible, Protestantism and the Rising of Science. It's a help to me. So I'm looking forward to hearing what you have to say. So thank you very much. Oh, thank you. Yes. Mobile phones. Please switch them off. Thank you very much.
Thanks, Sylvia. It's a great pleasure to be here. Have I turned this on?
That's right. This one's working as well? Okay, terrific. Yes, as I say, I'm laden with battery packs here, so if I start to look faint, it's not the jet lag, it's the combined weight of these batteries. As I was saying, it's terrific to be here back at the Faraday, and I'm grateful for the invitation. I always enjoy this very much. Let me start with an apology. I won't be able to stay for the whole week. In fact, I'm heading off tomorrow for another conference, but I'll certainly be around for the rest of today, and will be obviously on the panel this evening. The talk I have here is Religious Origins of Modern Science. I'm not sure if that's exactly the same as what's in your program, but the content, don't worry, will be pretty much what you would expect, I think. Let me just start with a few general remarks about what history can bring to discussions about the relations, the contemporary relations between science and religion. And I'm conscious of the fact that Ted Davis later today is going to be talking precisely about what history can do. But if we think about the disciplines that are involved in science and religion discussions, we can think primarily, I think, philosophy perhaps, or science itself, or theology, or sociology, which establishes patterns of belief and what people actually think about science and religion. But what is it that history does, apart from really describe what's happened in the past and set up the background, as it were, for the main event, which is how science and religion get on today? And what I would suggest right at the outset, and I think we'll see this emerge in the other talks on history that take place today, is that there are a lot of myths that surround contemporary discussions about science and religion, about their past. And those myths about the past colour the way in which people today think about relationships between science and religion. And the most fundamental of these myths about the past is that science and religion, by their nature, are going to be engaged in a perennial or ongoing conflict. That the way these two human activities are set up means that conflict between them is inevitable. And when people have this view about history, and Galileo, and to a lesser extent Darwin, are typically constructed as classic examples of this sort of conflict, that when they come to present discussions, their attitudes are already, to some degree, predetermined by a particular historical misunderstanding about how science and religion have been related. So part of what I want to do today is to dispel this myth about a perennial conflict between science and religion. And when I do this essentially as a historian, not as a religious apologist. It is the case, I think, that historians generally don't believe that there is a conflict between science and religion. That's historians of any stripe and of any range of religious convictions. So there's nothing really that I'll be presenting today that my colleagues in the profession would think was way off the mark, although as in every discipline there are scholarly disagreements about various things. And certainly I'll be presenting my own particular views about historical relations between science and religion. Okay, I'm going to focus on that period known to historians as the scientific revolution. It's a somewhat contested category, but for our purposes we don't have to worry about that. I'm really talking about the period in history between Copernicus and Newton, when a number of quite remarkable developments took place in Western science, and these are typically thought of as establishing the foundations of modern science. And it's in this context that I'm talking here about the origins then of modern science, which, say, historians regard modernity's beginning in the 16th and 17th centuries. I'm going to deal with a number of different categories I'm going to talk first of all about the motivations of some of the key figures involved in the development of early modern science. I'm then going to talk about the way in which religious convictions function as a way of choosing between competing scientific theories, where we have periods of scientific change. These periods are characterised by competition between scientific views. And sometimes religion can play a key role, not in the content of scientific views, but in the sort of background considerations that might lead people to prefer one kind of scientific theory to another. I'm going to talk about social and cultural sanctions. This may not be immediately obvious what I mean by this at this point, but I'll explain it in detail later. But the general point is that for science to become a prominent part of a culture, and this is a really distinctive thing about Western culture, the prominence of science, it has to be valued, and the values often come from outside science itself. The reason we value something is often independent of that activity itself. And my suggestion will be that religion actually provides some of the reasons why in the 17th century people thought science was a good thing to do, because it wasn't immediately obvious that it was. And then fourth, I'm going to talk about the kinds of presuppositions that you need to get science up and running. What is it that you have to believe about the natural world to make science a rational enterprise, and an enterprise that's worth doing? And then finally, and religion plays a role in that, finally then I'm going to talk about the way in which religious factors influence particular methods of investigation. And one of the distinctive things about science in the 17th century, particularly in the English context, is a move towards an experimental approach to the natural world. And I will argue that religious considerations had a major role to play in getting that that unique experimental approach up and running. So let me first speak then about motivations. And the point here is a very simple one. The vast majority of scientists, in fact scientists almost without exception in the 16th and 17th centuries, the period of the scientific revolution, had religious convictions. That's just a given. Okay? And we move on from there to say that beyond this, some scientists were motivated by their religious convictions to pursue scientific activities. So, summing it up, at a very simple level, there's a positive connection between people's religious convictions and their desire to pursue science. And I'll just give you a couple of examples of this. Here's Johannes Kepler. He's the astronomer who's generally credited with formulating what are known as 3 laws of planetary motion. Like he didn't talk about them in those terms. And it was Newton's achievement actually to collapse these 3 laws into a single universal law of gravitation. But these are brilliant mathematical formulations that we'll look at further on in the lecture. But here's what Johannes Kepler says in his correspondence. He says, I wanted to be a theologian. That was what I really wanted to do. And I was troubled that I couldn't be. But I now see, he says, that God is praised through my work in astronomy. So what Kepler was able to do was to understand his commitment to astronomy and astronomical investigations as a kind of intrinsically religious activity. And that then becomes a key motivation for him pursuing astronomy. The other example I've got here is Robert Boyle, who is probably best known to us as the author of Boyle's gas law. Okay, but one of the most important scientists in the 17th century in England, particularly in promoting an experimental approach to the natural world. And this is what Boyle says. I've got his dates there if you're interested. That discovering unto others the perfections of God displayed in the creatures is a more acceptable act of religion than the burning of sacrifices or perfumes upon his altars. And then he goes on to say that the rational contemplation of nature is philosophical worship of God. So here is the idea that scientific activity is an intrinsically religious pursuit, and that this then becomes a key personal motivation for being involved in scientific enterprise. Now, I'm conscious of the fact that we actually have in the audience experts on Robert Boyle, in Ted Davis here, and on Kepler in Owen Gingrich. So I'm going to have to be very careful what I say about these guys, but I will talk about them in a little more detail later because they're both key figures in the scientific revolution. And note, while we're on the topic, I hope you can see that the usefulness of natural philosophy is the work in which Boyle is talking about this idea. Natural philosophy is essentially, for our purposes, the word they have for science, physical science. And it's interesting that he's writing a book here attempting to justify the usefulness of science. Not something we have to do much these days, but nonetheless important in the 17th century. And part of Boyle's argument is that natural philosophy or science has very important religious implications, and that's a very good reason why we ought to be doing it and why we ought to be engaged in it. Let me just say, kind of parenthetically and in passing, that the Protestant Reformation, that great split in Western Christendom between the Catholics and the Protestants, is an important background to this new understanding of science as a religious vocation, partly because within medieval Catholicism there was a clear split between those engaged in a clerical profession, priests for example, and the laity, those who were not ordained. And theology properly was the activity of this particular group, that is to say, the ordained clergy, who were regarded as quite different. They got their status by virtue of a sacrament. They were, we would say, ontologically different from the laity. One of the things that happens in the Protestant Reformation is that people like Luther and Calvin say, there is no such distinction. There is no such distinction. There is a priesthood of all believers. We are all priests. And this idea then will form the notions of scientific thinkers like Kepler and Boyle, both interestingly Protestants, who could now say, actually, theology is not an activity that's purely restricted to the clerical profession for priests. It's actually something that we can all be. We are all priests, and therefore scientific activity, like a range of other mundane activities or vocations, is equally a priestly activity. Now, having said that, I'm not suggesting that Catholic scientists weren't also motivated by religious considerations, but I do think nonetheless that this is an important part of understanding why people in the 17th century, to some extent for the first time, could see science as something that was an intrinsically religious activity. And I'll say one more thing on this story before I go on. There is a kind of standard view about the emergence of modern science that sees the Middle Ages as a period when science and faith were all mixed up. And the idea is that science could never really get up and running until it separated itself out from religion and became an activity that was independent of religious consideration. And if you put this into a big historical, what I would regard as a myth about science and religion, science starts when the Greeks separate out notions of religious myth from rational activity, and the argument goes that falls in a heap when Christianity appears, and we get the Dark Ages, and then when science once again liberates itself from religion in the 17th century, that's when science gets up and running and starts its progressive path to where we are in the future. Now, I think that picture is actually completely wrong, and that the story is almost the other way around. But in relation to the Middle Ages, there is a clear separation between science and religion, partly for the reasons I've talked about, that there is a religious vocation and natural philosophy was quite separate. It was taught separately in the universities. Science or natural philosophy was taught in the Faculty of Arts and theology in the higher faculties. But what happens in the 17th century is that you get a collapse of the boundaries between science and religion, and they become mixed up and they become a similar kind of activity. One historian has referred to scientists as secular theologians. That is to say, we now have for the first time theologians who don't have a professional qualification in theology, but they're engaged in theological activity, and they regard science as precisely one of those theological activities. Now, whether it's a good thing to have amateurs like this doing theology is a question that you might ask yourselves. But these guys thought they were doing theology. So to go back to the big claim I want to make, rather than science and religion separating themselves in the 17th century, rather than the scientific revolution being a moving of science away from theology, in fact, they come together. And people like Newton and Kepler and Boyle and the English philosopher Francis Bacon, instead of separating religion out from science, what they're attempting to do is to establish a new Christianised science that will be, in their view, more Christian than the science that was based on the Greek philosopher Aristotle that dominated in these ages. Okay. So that at least is my take on that. Now, not all individuals in the 17th century are motivated by religious considerations. These two certainly are. And most individuals have a variety of motivations for pursuing the activities that they do, and our motivations are typically mixed. So I don't want to make too much about this question of motivation. And in a sense, I'm going to deal with the minor points as we go. And the second, what I'm going to say is that these get more important as we go down the list. Although I do think 3 is very important and underappreciated as an issue. Criteria for choosing between competing theories. Now, what am I talking about here? Philosophers in the philosophy of science will sometimes talk about the underdetermination of theories by the data. And what they mean by that fancy terminology is that in the history of science, sometimes you encounter 2 competing theories, both of which give you good predictability, and both of which cannot be distinguished on the basis of their capacity to give you the manipulation of nature and predictability of what's going to go on. They both give you great predictability, but they're completely incompatible with each other in terms of their theoretical content. And this happens, I think it happens in the history of science more often than we often think. And it creates a philosophical problem for what we might call what scientific theories claim to be real. Because very often in contemporary arguments about the superiority of science to religion, the claim is made, and I can quote here directly from Stephen Hawking, science works, okay? And the claim is made that because science works, therefore science must be true, and that's just logically false. The history of science is full of theories that work, and yet were subsequently overtaken by theories that postulated completely different views about the nature of reality. And the fact that you can have 2 competing scientific theories, both giving you the same kind of predictability, but entailing radically different conceptions of the natural world, highlights this point. And it was precisely this kind of situation that we had in the 17th century, when we actually had competing worldviews about the nature of the relation, how the solar system works. And you're probably very familiar with Galileo's championing of Copernicus's view that the sun was at the centre of the solar system and not the Earth. Okay, so you've got 2 competing views: one an Earth-centred cosmos and one a sun-centred solar system. But for a period, these 2 theories gave you about the same predictability. So it was difficult to choose between them on the basis of what they predicted alone. And if we can add into this a third theory proposed by Tycho Brahe, who said, okay, the sun is the centre, but all the other planets go around, the Earth is the centre, but all of the other planets go around the sun, which then goes around the Earth. And this was actually a compromise position. And the three positions are represented here, where this is the old Ptolemaic Earth-centred view, which has been, as you can see, discarded. Weighing in the balance here are the other 2 competing theories. And this one that's weighing the heaviest is the view proposed by Tycho Brahe, and this is the Copernican view with the sun at the centre. So what this illustration suggests is that this model here is actually the best one to run with. Now, the general problem I want to indicate, it's a very interesting problem, I think, in the philosophy of science. What do you do if you have an underdetermination of theory by data? That is to say, you've got two great theories in terms of predictability. How do you choose between them? And there are a range of criteria. Simplicity is a classic one, right? Simplicity. But again, there's no logical reason why the simple should be true and not the complicated. Beauty, aesthetic considerations are often another one. You'll often hear mathematicians and physicists talk about the beauty of the equations. And John Polkinghorne, who will be speaking tomorrow, is tomorrow? Yes. He will often talk about this, you know, and his teacher, Paul Dirac would often say, you know, look, if your equations are ugly, it doesn't matter if they work, just forget them. You really need beautiful equations, that's the thing. So it's almost at the point where the aesthetic considerations are the ones that trump. But so there's a way in which you can choose between competing theories. But actually your religious preferences also provide a way of choosing between competing alternatives. And some people, if you were to think that a sun-centered cosmos contradicted the Bible, that would give you a reason to prefer in this model. Okay? So religious considerations don't always give you what we might say a valid or, with the hindsight of history, an accurate way of choosing between alternatives. But the point I would make is they do actually function in this way in the 17th century in terms of choosing alternatives. And famously, of course, in the case of Galileo, that's why religious considerations did seem to play a factor in the trial of Galileo. I probably should have put this up a little early, but there's the explanation of the three systems. Okay, so here then we have the famous Galileo event. And I guess I'm not going to talk in detail about Galileo. We could have complete sessions on him, and I think in the past, with these Faraday schools we have. But what I want to say here is bear in mind that we tend to construct the Galileo event as a science-religion conflict. But another way of seeing it is it's really a competition between competing scientific theories. The vast bulk of scientific consensus was pretty much on the side of the Ptolemaic Earth-centered model. But Galileo was really exceptional initially amongst his colleagues in championing this radical new sun-centered view. And I just want to put in your minds here the idea that we sometimes just think about Galileo as a simple example of science versus religion conflict, and the church wanted to stomp on Galileo. It's rather more complicated than that. And one of the little wrinkles in the complication is that the church preferred one theory, and it had good reasons to do so. That theory they preferred gave good predictability and had the backing of the scientific consensus. The view that Galileo had had some evidence for it, but some evidence against it, classically parallax, and I won't go into that. But here we can see an instance where religious reasons play a role in the choice, in theory choice, when nothing else, where the other considerations are sometimes hard to give you leverage on which theory you should prefer. I'll just give you one contemporary, or relatively contemporary example. No, it's gone. So I've changed PowerPoints at the last minute, and there are two slides here. There they are. I'll tell you about them. In the middle of the last century, we know that the standard model for the cosmos now is the Big Bang theory, right? The Big Bang theory. But in the middle of the last century, there were two kind of standard competing views. One was a steady state theory that was propounded and championed at least by Fred Hoyle, who's an astronomer here in Cambridge. The Big Bang theory, the steady state theory, kind of proposed, and it really was like an Aristotle view about the eternity of the universe, that there was a steady state. It wasn't that everything started at a particular point. But George Lemaitre came up with this notion of called the primal atom, that later became Big Bang theory. And it became Big Bang theory because Fred Hoyle, who proposed the alternative theory, said that this is a joke name. He said the Big Bang theory is like a particle jumping out of a cake. Big Bang. So he lampooned this theory. But what was interesting was that the Big Bang theory had been propounded by a Catholic priest, George LeMaitre, and there was suspicion that the Big Bang theory, which has the universe not quite beginning in time, that's the wrong way to put it, but it does look more amenable to a creationist alternative than the Big Bang theory, which kind of has everything there for all eternity in some sense. So in the 50s of the last century, religious considerations played a role in which of these two theories you should choose. Now it's important to understand Lemaitre never attempted to get any religious mileage out of Big Bang theory, and specifically advised the Pope not to attempt to generate apologetic mileage out of this theory, and the Pope of course ignored him as popes would want to do. But anyway, all I want to say is that we have here another example of the way we've got two competing theories. Religious considerations can play a role. And if we move this right now to the 21st century, where we still have, in a way, two competing theories. We have a universe theory and a multiverse theory. To some extent, I think, people who have no religious convictions will often opt for a multiverse view because they see it to be you don't have to deal with the awkwardness of the anthropic fine-tuning of the universe if you posit a multiverse theory. So it's not merely that if you have a set of religious considerations, they motivate you to accept the theory that is most hospitable to your own views, but if you're an atheist, you're similarly motivated to opt for a model that confirms your own views. So once again, we tend to think about science as kind of value-free. In a sense it is, but nonetheless there are value considerations that are always in operation. And we've already seen this in regard to motivations, and now I'm suggesting that this plays a role in relation to theory choice, if nothing else can help us choose between theories. So religious considerations or atheistic considerations play that kind of role in science. Okay. Now let me move on to, we've moved on already, social and cultural sanctions. Now, I said I'd try and explain this in a little bit more detail, but look, here's the basic point. Now in the 21st century in the West, we tend to think about science as perhaps the most impressive activity that the human race has ever been able to come up with. We tend to think about the pronouncements of science as being the most reliable ones. We tend to think that the scientific method is really the best way to arrive at uncontroversially an objective view of reality. Now, I'm not going to say that's wrong, but I'm saying that that view of science is a view that emerged relatively late, and it starts really from starts developing in the 18th and 19th centuries, and now I think we tend to think of science really as a knowledge-generating enterprise. It provides the model against all other putatively knowledge-generating enterprises have to measure up. So in science and religion discussions, really the sort of claim, science holds all the cards, and religion very often has to attempt to justify itself in terms that science dictates. That was not the case in the 17th century. In the 17th century, the new sciences were extremely vulnerable, and it was religion that held all the aces, as it were. So for science to be successful in the 17th century context, it had to appeal to various values that lay outside it. And the key set of values that are going to make science an enterprise that's legitimate, these are going to be religious values. So the argument I'm going to put to you is that in the 17th century, part of what makes science successful was its capacity to appeal to religious values for its religious legitimacy and religious usefulness. And we've already seen that to some extent in the statements of Kepler and Boyle about science being an intrinsically religious activity. This did relate to their personal motivations, but it also related to their appeal to the question, why should we be doing this? And that's why the title of Boyle's book was The Usefulness of Natural Philosophy. And it's interesting that his arguments are not natural philosophy will give us these material benefits, it's going to generate technology and good things and so on, but rather that science will have very good religious outcomes. It will be religiously useful. And that was a key part of the arguments of people like Boyle and Kepler. And in appealing to religion, what they are attempting to do is to appeal to cultural and social sanctions, to say science is an inherently useful activity and something that we ought to be doing. So that's one thing I want you to bear in mind. The other thing is to think about the fact that the centrality of science is a really quite distinctive feature of the modern West. Okay? Although this clearly is changing. But my argument would be that modern science, in a sense, has its origins in the West, and that there's a particular set of cultural reasons for that being the case. And let me be clear on this. This is not a matter of there being brilliant people who come up with scientific theories. It's not that. You need that, but you need more than that to have a successful scientific culture. In addition to that, you need what I would call consolidation. You have to have a way of appealing to the values of a society that says, you know, not just that these bright people should be encouraged, but that really people understand scientific investigation as something that the whole society needs to get behind and move science from the periphery, as it were, to the centre and give it an ongoing consolidation and longevity. So let me put it this way. We see indications of scientific activity in every culture. We see them in ancient Greece. We see them in medieval Christendom. We see them in medieval Islam. We see them in China, crucially, right? We see scientific activity in all these places, but we see consolidation primarily in the West from the 17th century on. And so that's not merely kind of sporadic boom-bust patterns of scientific activity, but where science becomes something that the whole society values, and it moves from the margins into the centre, and it continues to be a key and central feature of the culture. So what the question then becomes, well, and I'll use, let's say, a contrast case of China. In the Middle Ages, China is way ahead of the West technology, in terms of technology. You know, Voltaire has that famous saying where he says, you know, we're basically primitive compared to these guys, okay? May well be in 100 years' time that will be true again, okay? But certainly for the present, or certainly for the last 3 centuries, that has not been the case. And Joseph Needham, there's a Needham Centre here in Cambridge, which is to do with science and civilization in China. Here's the famous title of Needham's book. Needham asks the question, what happened in China and what happened in the West that didn't happen in China? Why did science take off here but not there, given that they were so far ahead of us in terms of technology? And one of the answers that Needham gives is to do with the sets of cultural values that we have. So once again, we have the idea that cultural and religious values are an important part of what leads to the encouragement of scientific activity. And you can see where I'm going with this. Religious values, crucially, are a key part of that repertoire of values that exist in Western culture. And so the argument will then be we need to look for what's distinctive about Christian values that might make possible not just the emergence of science, that's not what I'm talking about, because we see scientific things emerging all over the place, but the consolidation of science. Okay, so Robert Merton, a sociologist, gives us a few clues about this. Robert, you can see his dates there. Merton, I think, one of the most important sociologists of the 20th century, worked not only on science and religion questions, which is what he did his dissertation on, but a lot of other elements of sociology. He's the guy who gave us the term self-fulfilling prophecy, for example. But his early work was done on this very question. What are the cultural values that made science take off in 17th century England? And what Merton did was he did a statistical, as others had done at the time, a statistical analysis of the membership of the Royal Society. Royal Society, I'm sure we're all familiar with this. It kicks off in 1660 in England, one of the earliest scientific institutions. And according to the analysis that Merton was using, there was a significantly higher proportion of Puritans in the membership of the Royal Society than there were in the general population. And this led Merton to the view that there must be something about Puritan values, right? A kind of this worldly asceticism, to borrow a term from the sociologist Max Weber, that motivated their scientific endeavours. Now, as it turns out, the statistical data that Merton used was perhaps not as accurate as it might be. And it's probably not the case that the figures were exactly as he saw there. That's not my concern. My concern is rather the principle that Merton is operating with here, in that what he wants to say is we can attempt to set up correlations between particular religious ways of understanding and motivation for scientific activity. So the Merton thesis, as it's known by historians, is a thesis that links the Puritan ethic with success and motivation in the direction of scientific inquiry. If we go back to a big question, how do we move science from a marginal activity into the centre of culture? One of the things Merton wants to suggest is that it's religious values associated with Puritanism, or more broadly Protestantism, he would say, that motivate scientific activity. Now, this is a somewhat controversial thesis, so I'm not going to push it too far. But let me just put this again, a graph where the statistical basis, I think, is highly contestable, but nonetheless it's suggestive, and it's major science by nationality in this crucial period of the scientific revolution. Wow. Gee, the English are way out ahead. So, if we were to do this for cricket and rugby, we'd probably have a similar thing. Except Australia would be here. But as for the cricket, that remains to be seen. It's a cultural in-joke there for those of you who
Pray on, mate.
We'll see. At any rate, so you could ask questions like, what is it about the soil in New Zealand that generates good rugby players? Okay. My theory is they don't do anything else very well. They might as well be good something. I see we have a Kiwi in the audience. But you can ask, it's a very interesting question about what is it about the cultural milieu of places that generates excellence in particular spheres of activity. And it does seem that the English are well ahead. You can't put this down simply to Catholic Protestant, because the French who are coming second in this particular race are, for the most part, a Catholic nation, as are the Italians and the Germans coming forward. There's a really interesting absence here. One of the most powerful nations of this period doesn't seem to get a mention, right? And that is Spain. Right? So the Iberian Peninsula doesn't seem to be there. Now, I think part of the reason here is that natural history was left out of this thing. We could argue the toss about who counts as a major scientist, who's doing the head count here. But this is really quite an interesting suggestive thing to say there's something not something in the water, but there's something about the culture that leads to this kind of activity. And one suggestion is that it's a particular religious complexion of English society in the 17th century that leads to this predominance in religious activity. Now, I won't develop this argument in length. There's much more that can be said about this. But I will put up a quote here from my I guess he's a colleague in Sydney, Stephen Roger, who's writing a 5-volume series on the emergence of a scientific culture, where his premise is precisely this question about why does science emerge in the West? Why is it that it has a predominance that we don't see in any other time, or he would argue in any other place? And he says it's to do with legitimation and consolidation, as you can see in the quote. And he says it's not to do with this separation of religion and natural philosophy, but rather that natural philosophy can be accommodated to projects in natural theology. And he will go on to say that the success of science in the 17th century depended crucially on religion being in the driving seat. Okay, so again, it's not that science and religion come apart after a cosy period together in the Middle Ages. On the contrary, it's the fact that science and religion come together in a very productive way in the 17th century that gives science its legitimation and legs. Okay, so that's that much for legitimation. There's much more we could say about that, but I want to move on into presuppositions. We've still got two important areas to go, presuppositions and methods of investigation. And presuppositions is not unrelated to the question of cultural values and so on, because one of the things that comes out of Joseph Needham's analysis of why science takes off in the West but not in China is to do with the fact that in the West you have a particular conception of the laws of nature, and I'm going to talk about laws of nature as one example of a set of religious presuppositions. Johannes Kepler, who we've mentioned earlier, is one of the guys who comes up with, I think, a remarkable set of laws of nature which map mathematically onto the motions of the planets. For those of you who don't know them, here's a quick education in those laws. The first law is that the paths of planets are elliptical, and they're ellipses with the sun at one focus of the ellipse. Pretty harmless. The second one, I think, is more interesting mathematically, and it says that as the planets carve out their paths, the area under the curve is equal in terms of the time taken. So the time taken as they move around, the area under that curve is equal. So they move faster and slower is the basic idea. But there's a very interesting mathematical relation that you see there. And the third one is really quite remarkable, I think, and it says that the square of the time of the period, the time it takes for the planet to complete its rotation, is proportional to the cube of its mean distance from the sun, essentially the radius of its orbit. So you've got this remarkable mathematical relation there between how the planets operate. And it's a question you might ask, why should it be the case that the cube of the orbital period of the planet is proportional to the square of its mean distance from the sun? It just seems to be a remarkable thing. And there's this famous statement by Eugene Wegner about the remarkable effectiveness of mathematics. Why is it that our mathematical constructions map onto the natural world? And Kepler's answer was simply the old Platonic answer, that God is a geometer, and that God stamps onto the world a particular set of mathematical relations. And this idea is going to play a crucial role in the emergence of the idea of laws of nature, which appears for the first time in the 17th century. The idea that there are laws of nature. And the idea of a law of nature, it's not an analogy, it's a literal conception that God actually stamps or instantiates laws, that he invents laws and then he impresses them on the natural world. The French philosopher René Descartes is probably the first guy to come up with this idea in a strong way. You know Descartes as the cogito ergo sum guy. We think of him primarily as a philosopher. He was really much more what we would regard as a scientist, and the philosophy came, as it were, as a post facto justification of his scientific activities. But he's a much more important scientific figure than we often give him credit for. And here's his idea about what a law of nature is. God imparts motions to matter, he says, and then he preserves this matter in the same way and by the same process by which he originally created it. And what he's attempting to do here is, in the 17th century, we get this emergence of a corpuscular or an atomic theory that the whole world is particles, it's matter in motion, tiny microscopic particles. What gives those particles their orderliness? Well, Descartes says it's the fact that God creates them and he stamps a particular order on them, and that the laws by which they operate, the laws of motion, for Descartes is God constantly impressing on these particles his will that they behave in a particular regular fashion. Right? So the laws of nature are the will of God constantly or consistently imposing itself on matter to ensure that it behaves itself in this rational, lawful fashion. And that's why when we observe nature, we can actually infer the rational, mathematical lawfulness that lies behind them, because there is a mind there that's actually generating. that lawful operation. So for Descartes, if you have a particle moving through space, what that is God, as it were, constantly recreating that particle in different spatial locations according to a particular mathematical pattern. Descartes, of course, is not the only one. The English have a somewhat different conception of how laws of nature come into existence, but the idea, the basic idea is exactly the same, that God is the author of the laws of nature. And here's Robert Boyle. The laws of nature, they're not intrinsic to matter, is what he's saying here. They don't necessarily arise out of the nature of matter itself, but they depend on the will of God. Okay? So matter is inert, it has no capacities or capabilities of its own. The only reason matter behaves in this rational, lawful fashion is that God at every instant is making nature behave in that fashion. And that's exactly what a law is. A law of nature, understood in this context, it's a law of God, it comes from the divine will. One further example, Samuel Clarke, who this may be a name unfamiliar to you, probably the most sophisticated philosophical theologian of the 17th and 18th centuries, significantly underrated, I think, but known primarily as Newton's spokesman in the great controversy between Newton and Leibniz. Okay, there's a very important Clarke-Leibniz correspondence where Samuel Clarke represents a Newtonian worldview, but here he's giving the basic idea that Leibniz didn't agree with. But anyway, the course of nature is nothing but the arbitrary will and pleasure of God exerting itself and acting on matter continually. Right? That's a really good summary of the 17th century English conception of what a law of nature is. So we tend to think of nature having its own logic and its own course, right? That's really a vulgar conception of nature, says Clarke. What we need to understand is that nature has no capacities of its own, and that the lawfulness of the natural world is God constantly acting on matter. That's all that makes it regular and consistent. And finally, the guy who Clarke was championing, well, it's actually not Newton, it's Roger Coates in the preface to Newton's Principia, but Coates and Newton, and while you're here in Cambridge, you can go and see, by this parenthesis, go and see Newton's room in Trinity College, and I think they planted an apple tree in the front courtyard. Obviously replete with great meanings about this mythology about the apple and so on, but Trinity College, of course, is the place where Newton did all this wonderful scientific work. Anyway, Coates worked with him very closely on the second edition of the Principia being Newton's most famous work where he develops the law of gravity. And he says the business of true philosophy or science, is to inquire after those laws on which the great Creator actually chose to found this most beautiful frame of the world, and not those by which he might have done so had he so pleased. Now, it's a bit unclear what he's getting at here. He's having a bit of a dig at Descartes, but the point is that God chose, somewhat arbitrarily, the argument would be, a set of laws to impose on the natural world, and in order to find out what those laws are, we need to investigate nature. So when we're investigating nature, we're essentially investigating the laws that God chose freely to impose on the natural world. That's the argument that he's putting. So to go back to the general point I want to make, the assumption that I think is pretty widespread now, that there are laws of nature and that science investigates the laws of nature, goes back to this religious conception that the natural world has on it laws that are originally authored by God. It won't be long before in the 19th century these laws of God become laws of the natural world, and that they are once again seen to be intrinsic to nature itself. But again, if we ask the question, why is it that nature has this mathematical intelligibility? Certainly historically the origins of that conception go back to this theological understanding of laws of nature from the 17th century, and we've just got used to the idea. Okay, moving on very quickly, and the last thing I want to talk about is methods of investigation. And I'm going to give you a very summary version of this since we're getting close to the hour. But experiment as a way of approaching science is relatively recent. It starts in the 17th century. Before that, we have an Aristotelian understanding of science. Sometimes people say Aristotle was a kind of armchair scientist. Well, he wasn't. Aristotle was very big on observation. So Aristotle's science is observation-based, and experimental science is also observation-based. But here's the crucial difference. For Aristotle, we can come up with how nature operates just by using common sense generalisations about what we observe in the natural world under normal conditions. Under normal conditions. And indeed, for Aristotle, if you manipulate nature and then watch it, you're not actually measuring nature at all. You're measuring something that's completely artificial. So Aristotle has this very important distinction between the natural and the artificial, and the natural and the violent. Okay? And that's done away with in the 17th century. And there's actually some important theological reasons to do with an idea of creation, but I won't go into that. But what happens in the 17th century is we get an idea of experiment into the natural world where you do manipulate nature. And in fact, it's only by manipulating nature that you get to see what it's really like. In a way then, although Aristotle, the old view, and the new science are both based on observation, they have quite different understandings of how you do that observation. So why is it in the 17th century people start to interrogate nature with much more suspicion, as it were? They don't rely on their common sense understanding. Why do they do that? And one argument that I suggest is it's to do, you can read the book, that's why I'll give you the short version. This may well be in the bookshop, I haven't checked. But, it's to do with the Christian idea that human beings once had a perfect knowledge of nature, but that when they sinned, in the story in the Garden of Eden where they rebelled against God, they fell away from their original perfection and they lost all their capacities to know things in any veridical or reliable way. Okay? So, just to give you an example, can't go past John Calvin as a Protestant, but the corruption of our nature, he says, was unknown to the philosophers. He's talking about Aristotle here, who in other respects were pretty bright. Then he goes on to say, corruption doesn't reside in one part only, but it pervades the whole soul and each of its faculties. Now here he's having a go not at Aristotle, but at medieval Catholicism, who tended to see the fall in purely moral terms. It was a moral incapacity. And what Calvin says is, no, that incapacity extends right across the board also to our cognitive and observational capacities. So the idea was that, putting it crudely, in medieval Catholicism, we were morally flawed, but in terms of our knowledge-making apparatus, that was all right. And what Calvin is saying is, no, actually our knowledge-making apparatus is as corrupted as our moral apparatus. Okay? And I'll just give you Calvin. He says, part of the reason that Aristotle didn't understand this is you can't actually understand human nature itself because it's so fallen. So how do we understand human nature? Not through an anthropology, but for these guys, by reading the Bible and by reading the story of the fall. Now, what are the implications for this for how we know the world? Well, the implications are basically this. We can't simply intuit naturally from our observations of nature. We've got to be far more critical in our interrogations of the natural world. We can't trust our sensory observations. We have to supplement these with things like telescopes and microscopes, and we use experiments to penetrate nature's secrets, partly because nature itself also has fallen away from its original perfection, and nature is no longer transparent. It once was the case that it was, it is no longer, but interestingly, we can also recapture, to some degree, the original perfect knowledge that Adam once had of the natural world. And science is the means by which we do that. And in a sense, science is a redemptive process by which we re-establish the perfect knowledge that Adam once had of the natural world. Now that in a nutshell is the story of a very long book, but I think you get the general idea. I'm going to give you Blaise Pascal. Pascal, of course, is a Catholic, but he's a Jansenist Augustinian Catholic, so he's got, in a sense, Protestant sympathies. And this was the problem, he says, with the ancient philosophers. If they realised our excellence, they forgot that he was corrupted by sin, and they fell into pride. that if they realised our infirmity, they became sceptics. They despaired of any knowledge of nature. So here he distinguishes between the basic division of ancient philosophy, the Stoics and the Epicureans, and the dogmatists and the academicians. The academicians were the sceptics who said you can't know anything, and the other philosophers were the ones who were confident that we could know everything. But he said they both were wrong. We can know something, but we can't know it with certainty, these ancients like Aristotle once thought. And so here's where we find ourselves in this Christian Protestant, essentially Protestant Augustinian from Augustine, this view of human nature. We perceive an image of truth, right? We know that there's a truth out there. This is the old Adamic, this is our inheritance from Adam. We know there's a truth out there, but we possess nothing but ignorance and falsehood. We're equally capable of ignorance, absolute ignorance, and certain knowledge. So obvious is it that we once enjoyed a degree of perfection from which we have unhappily fallen. So we know there's knowledge out there, we want to get it, but we lack the means. And in the 17th century, science becomes the means for a partial restoration of that lost knowledge. And I'll just give you the classic quote, I think. Francis Bacon, who sets up the experimental approach to nature for the Royal Society early in the 17th century. Man, he says, fell from his state of innocency and from his dominion over nature. He had a power over nature. Both of these losses can, in part, be repaired, the former by religion and faith, but the latter by arts and sciences. So science becomes the means by which we recapture a knowledge of nature that we once had. Okay? And so we have a motivation for pursuing science and a way of understanding that it's not going to be easy. We're going to have to do basically experimental stuff in order to penetrate the secrets of the natural world. So, again, more of the same. Knowledge is to reinvest to human beings the sovereignty and power that we once had in the first state of creation. And I can do one more. Okay, this is a kind of smoking gun. Robert Hooke. Every man, he says, both from a derived corruption, innate and born within him, okay, that's original sin, and from his breeding and converse with men is likely to slip up and subject to all sorts of errors. These are the dangers in the processes of human reason. The remedies of them all can only come from the mechanical and experimental philosophy. So experimental science, then, is the remedy for original sin, in a nutshell. Okay, second last slide, just summing up all that experimental stuff. These are the features of this new approach. It's probabilistic rather than demonstrative. Aristotle's science was demonstrative. We know appearances, but we can't penetrate to the essences of things. You need to have lots of people doing this, and you need to do it for a long period of time. That's a really key thing, right? This is really quite unique to the 17th century. Lots of people have to be engaged in this, and you have to do it, you have to be in it for the long haul, right? It's much harder than you would have thought if you were out of field. Knowledge is based on experience rather than speculation. We need to augment our fallen senses with instruments, telescopes, microscopes. Fallen nature, nature itself is imperfect, and therefore it has to be investigated aggressively. It's not in its natural state. And then method then is like a therapy that we apply to overcome the limitation of our reason and our senses. Okay, so summing it up then, historically science and religion have interacted in a number of different ways. Historians now talk about the complexity of science-religion interaction. So my message here hasn't been, religion has always been friendly to science, it's motivated, right? It hasn't, well maybe it hasn't, that's all I've told you, but that's not the case. It's complex, and there are pluses and minuses. In the 17th century, though, religion played a significant positive factor in the emergence and then crucially the persistence of science. It's the persistence that is a key thing here, a key distinctive thing. Science is legitimated by religious values. We have a new conception of laws of nature that provide key presuppositions to a new way of doing science that's unique to the West. The fall of experimental science, the fall of experimental science, so we have both methods and motivations, all of methods and motivations and legitimation involved in the importance of this idea of a primeval fall. And then some further reading. Thomas Dixon's book is a really great introduction. There's a lot of history in it, as well as the rest. Galileo Goes to Jail talks about a number of myths in the history of science and religion, and the Cambridge Companion, a series of chapters, but there are 4 on historical background as well as some substantive issues. Let me finish there, and I think we move to questions. Is that right? Thank you.
Thank you very much. Absolutely fascinating and illuminating talk. Now we do have time for questions before coffee. We have a roving microphone, so we can record your question on tape. And if you could, if possible, keep your questions short so there's time for plenty of interaction, that would be great. Okay, thank you.
I just wondered if you could, I just wondered if you could clarify your thesis that you presented, because I always assumed naturally that it was from eating from the tree of knowledge that man fell. So it was from his pursuit of the knowledge of the divine that he fell, and that previously he was in a state of innocence of knowledge. So actually that's what instigated the fall, and therefore that's not what we're trying to respond to, but what we're trying to absolve ourselves of.
Yeah, I mean, it's a very good question, and it's precisely this question that Francis Bacon has to answer when he wants to present this interpretation of the fall and why the pursuit of knowledge is a good thing and not precisely the thing that precipitated our fall in the first place. Okay. So, and again, part of the background here, and you may be aware of this, is that curiosity, which we tend to think as a positive intellectual virtue, like curiosity we think is a good thing, that traditionally curiosity had been regarded as a bad thing, precisely for these reasons, that curiosity was linked to the quest for some kind of knowledge that had precipitated the fall, and therefore the bounds of knowledge had to be very carefully restricted. So when Francis Bacon comes up with an idea about the fall as somehow promoting a version of human knowledge, he's got to be very careful about how he finesses precisely your question. Wasn't it the case that the pursuit of knowledge got us into this problem in the first place? And what he argues is, and then he uses scripture to actually interpret scripture, and then he refers to a passage in Corinthians where in the Vulgate it talks about scientia inflat, knowledge puffs up, but charity edifies. So Paul, it must be from thinking Corinthians. So how does he deal with what he says? Is, okay, there are 2 kinds of knowledge. There is in fact the knowledge that puffs us up and makes us proud, and interestingly, may not be interesting to you, it's interesting to me. In the taxonomy of the medieval vices, pride, of course, was the worst of the sins, and pride typically is what we regard as having led to the fall. But curiosity was a subset in the arrangement of the virtues, a subset of pride. Now, where was I? Okay, so knowledge puffs up and makes us proud. So what Bacon has to say is that's not the knowledge we're looking at. And the rest of the quote goes, caritas is charity edifies. Right? This is beginning again with Vulgate. So he says knowledge puffs up but charity edifies. So Bacon says the reason we pursue knowledge is not proud knowledge, it's charitable knowledge. And he aligns the virtue of charity with knowledge and the virtue of curiosity with the kind of knowledge that Aristotle and the medieval scholastics were interested in. This useless knowledge, this disputation, this speculation, that's just arguing, but a knowledge that actually generates positive outcomes is a charitable knowledge because it conduces to the welfare of the human estate. So it's a really good question because it's precisely at that point of what is the reason we pursue knowledge. And what Bacon wants to do is to align the pursuit of knowledge with charity, which is the complete opposite of pride. It's the queen of the supernatural virtues. And so the pursuit of science then is not knowledge for its own sake, knowledge for the promotion of human welfare and the promotion of human welfare is then aligned with charity, and so that the whole of science becomes this charitable enterprise that promotes welfare, and that again is a key part then of its justification. And when we get to people like Boyle, I think we find precisely the same kind of thing being argued, that Boyle is going to say that the reason we pursue this is for charitable means. So love of God, the pursuit of science is really love of God and love of neighbour. Love of God insofar as by studying the natural world we get to understand things about God's power and wisdom, but also we get an understanding of how to manipulate the natural world that gives rise to charitable outcomes. Right? So that's one answer. That's one element of the answer to the question. And the other one that's linked to that is the fact that what Bacon wants to do, and again here you might say this is theologically dubious, but what he wants to do is to say through human activity to some the original perfection of the garden, and insofar as that God commanded us to have dominion over nature, and that he says this to Noah when Noah comes off the ark in Genesis, whenever the ark was, Genesis 10, around there roughly. Dominion, and the means by which we have dominion is through our knowledge of nature. And so there is a divine command that dominion, and science is the means by which we do it.
Motivation to believe, faith. Wasn't it Pascal who said famously, the heart has... Years later, Kant, who was a practicing Christian, pushes in different words, said, reason must give way to make way for faith.
Yeah, I mean both true. How this is going to be relevant here. Yeah, the heart has its reason, which reason they want. I mean, for Pascal, this is really wholly consistent with his Jansenist Christianity that says, our human reason has fallen, and this means we need desperately to rely on faith and revelation. And it's interesting that Pascal, of course, is a very important scientist. Boyle's got his law, Pascal's got his principles. But Pascal was certainly engaged in scientific activities. So he was hostile to Descartes because Descartes has much more faith in human reason than Pascal had. And to some extent, Pascal confirms my view that experiment goes hand in hand with a Protestant Calvinist Augustinian anthropology, and Descartes still very much operating, I think, with a much more Thomist, optimistic view about what you can know. Kant, yeah, I won't say anything about Kant. Tim wants to say something. The philosopher can answer.
Yeah, just a brief word on Kant. Not that I'm a Kant expert or anything, but Kant made important contributions to science as well. He's part of this long tradition of philosophers who are both scientists. But for Kant, we can't have knowledge of God at all. He's totally repudiating the whole tradition of natural theology. But he critiques reason itself. Science too only gives us knowledge of the ways our mind inherently structure the world. We really don't have knowledge of nature as it is in itself. And then God becomes just a practical postulate for us. We need to postulate God in order to make sense out of morality, which we're committed to. So it's a sharp break from all the stuff that's gone before it. Yeah.
That was my point.
Yeah, that's a good summary of Kant. Thank you very much.
Have you ever looked at the situation in Germany in 1930, where all of a sudden you seem to have a very large number of Nobel Prize winners? If my understanding is correct, this was essentially a Jewish scientific religion. Is this just an aberration, or were there some cultural factors that led to this extraordinary scientific blooming in Germany in the 30s?
Yeah, again, this is a really intriguing question about links between quite specific religious or ethnic groups and scientific success. And there's been some interesting work done in sort of religious heterodoxy. And the example in England earlier is Quakers. The Quakers seem to be disproportionately successful at science. And there's some discussion about whether the stats bear that out. But one kind of argument is to do with the social exclusion of certain religiously heterodox groups, and the fact that science becomes one option that's available when others are not. And so that was part of the argument in relation to Quakers who were excluded by the Test Acts from a whole range of various activities, and science became an option that they can pursue. To answer the very first question, you said, no, I don't know in any detail about the situation in 1930s Germany. But it could, I'm thinking that this exclusionary theory might account for that. But certainly the success of Jews in science is a quite remarkable correlation. And that applies, of course, to secular Jews in the present as much as the other. That's probably all I can say on that point. It's a very interesting observation.
Professor Harrison, is there some kind of tension or contradiction between religious origins of modern science and the complexity thesis? These religious origins means that religion creates the modern science?
Yep. Okay, yeah. So here's the thing, I guess, in people who talk about science, religion and history, as I said, there was the famous, the myth of warfare, the perennial warfare. No one believes that anymore. And the standard model amongst historians has been, I think, to some degree, complexity. Science and religion relations are complex. And I personally think that's a little bit of a cop-out, that we've got to be better than that. Just say, gee, it's all really complicated, I'm going to show you. And that's why I think, if I were to locate myself in this continuum, and if the warfare myth's here and the complexity is here, I'm a bit more over this way that says religious factors are really key and perhaps even a necessary condition for the emergence of modern science in the West. So to that extent, is it just complex? No, we've got to do better than that as historians, I think, and we've got to look for trends, and I think there is a strong trend between certain kinds of religious convictions and the emergence of science in the West. That's the short answer.
Just a comment and a question. The comment was on the question about the over-representation of Jewish people in some of the community. There is a nice talk by Noah Ephron on that very issue, which people will find on the Faraday website. I won't try and tell his story, but it's an interesting story. But just to comment that in the top 21 elite universities in America, the proportion of Jewish people amongst the Sunday community is 16%, and the proportion of Jews in the American population is less than 2%, less than 1% actually. So, and he's reflecting on that. So that was the comment. The question actually was quite different. It was back to laws of nature. So in Augustine, there's some interesting passages where he talks about what is translated into the English as laws, and it sounds like they are precursors of the laws of the 17th century. I just wondered if there is any linkage there between Augustinian laws, as it were, quote unquote, and these Descartes and Boyle and so forth. Could you comment on that?
Yeah. Okay. Thanks, Dennis. Now, if I had a room full of historians here, they'd probably all be talking about laws. In the ancient Greeks, will talk, depending on how you translate it, about laws of nature. And Augustine certainly. So there's in the patristic writings, there are things that are typically translated laws of nature, and I wouldn't necessarily argue with the translation. But it seems to me that the key difference is to do with for both the Greeks and Augustine, the laws are intrinsic to the natural order. So Augustine's view about how things operate, and this is true, of course, of Aristotle himself. All Aristotle's causes, in a sense, are inherent in natural objects. But the view that Augustine has is to some extent inherited from the Stoics, and it's a view about God implanting in things potentialities and capacities that develop over time. And this is a conception of seminal reasons, rationis seminalis. And this is how Augustine gets around the difficult problem of whether the world was created in six-day periods sequentially, or whether it was created all at once. Because there's a passage in Sirach that, unfortunately, in the Latin version that Augustine was using, suggests that God created everything at once. And this was actually the view that Augustine had. God didn't create in a six-day period; He created everything at once. Then you've got the exegetical problem in Genesis of how do you account for the sequential creation? What Augustine says is, all right, God creates everything at once, but He implants in things a potentiality that then subsequently develops over time. So the sort of order of nature that Augustine has in mind, and the way that God controls things, is that He's already intrinsically implanted in things the orderliness. So I want to be clear that my point is not that you don't get a conception of the orderliness of nature before the 17th century. And if I was going to be speaking most properly, I'd say even laws of nature, you certainly encounter that expression. But the particular view of laws of nature that you get in the early modern period, because it's combined with the matter theory that wants to say the whole world is corpuscles, tiny particles in motion. Now the question is, where does their capacity to act in a regular law-like fashion come from? And they insist that it's not to do with their inherent capacities. It's to do with externally imposed capacities, although, again, that's something that I would say. So I guess my point is that it's the difference between an order intrinsic to nature that could be understood as lawful, and the laws as being externally imposed on the natural world. And it's the latter that's the distinctive thing about the 17th century conception of laws of nature. Is that?
Excuse me.
As a historian, is there any evidence that people who live north of the Arctic Circle came to any conclusion about the Earth going around the sun or the other? But if you live north of the Arctic Circle, it's quite clear that the sun doesn't go around the Earth.
Why is it? Sorry, excuse me. Why is that clear?
Oh, at certain times of the year, you can see the sun doing that in the sky and not disappearing behind the Earth.
That's just relative motion.
But yeah, why wouldn't that just be couldn't that be? But you still see the sun going around like, it's not going around the Earth.
It's not Earth-centered, is it?
Good point. Right.
There's not much of a voice. The sun could still be precessing on next.
No, I mean,
The sun is
we can
precessing on a cone above the Earth.
Yeah, no, I now what would it look like? Yeah. No, I think the short answer is no. I don't think there is some evidence of that. But it's a very good point.
I guess it was too complex for a simple solution to be thought out, or they were too busy keeping warm.
Indoors, in their igloo.
Worrying about the cricket.
Hi, this is about the correlation you try to make between the Protestant affirmation of the general priesthood and more people willing to investigate God and celebrate them. Can't we argue the other way around? Considering the original position where theology is meant for a particular class. So, okay, that's proper theology can be done only by that class.
Mm-hmm.
Science is a way of celebrating God through other ways, which is not open to theologians.
So can you just say a little bit more? So I'm clear on the fact that in the Middle Ages we've got a separation where the theologians do their work in the theology faculty and the natural philosophers do theirs. And that breaks down in the 17th century, right? Now, so what was your point in relation to that?
No, you try to make the point that the Protestant Reformation
Oh, yeah.
of the general priesthood
Mm-hmm.
so kind of attracted more people to the business of investigating God, and science was one of the ways of doing it.
Okay, yep.
So that would be the other way around.
Right.
Theologians do proper theology, and science is a way meant for others who are not in theology. the chosen priesthood.
Oh, okay, yeah. Yes, certainly. What's this is if I've understood you correctly, that what happens is that science by the 19th century will actually take on the status that was once occupied by theology as the so-called queen of the sciences. And that's a complicated story, the queen of the sciences business. But so that the prestige that was once associated with theology is subtly transferred to the scientific community. But what, in my view, takes place is that this is to do with the vestiges of the it brings scientific vocation carries along with it vestiges of the social legitimacy and authority that were once given to theology as the queen of the sciences. And looking into the future, it's going to be very interesting to see the extent to which that continues. So my sense is that science in the West is being subjected to increasing criticism, and maybe that's a function of the fact that the vestigial gloss of theology is starting to wear off. But that's all I probably want to say on that in general.
Got time for one last question.
I'm struck by the symmetry of the, in modern times, faith being challenged by science to justify itself, and that in the 17th century, the usefulness of natural philosophy being, and science being justified by theology. And I'm wondering what we can learn in the modern times from the 17th century.
Well, look, it's a very good question. It's to do with the fact that what seems to us to have obvious value now. One of the wonderful things about history, it shows us the relativity of the things that we think are really valuable. But what I find quite compelling about the sorts of things that were valued in the 17th century, this is a bit of nostalgic anachronism, is that they valued science because it was morally formative. And the chief justification for pursuing science was made those who pursued it better people. And that's really very interesting. It's a kind of old-fashioned view about, in general, what the pursuit of knowledge should be about. It's not merely about coming up with better widgets, although these things are good to have, anesthesia and those kinds of things. No one's going to want to go back to a time when we didn't have those. But nonetheless, the relativity of the sorts of things they value, I've always had a very striking, and as a historian, you really have to put your prejudices, not your prejudices, but you have natural assumptions about what sorts of activities are worthwhile and not. And when we put those aside, it's very interesting to see these discussions going on. Jonathan Swift, of course, famously in Gulliver's Travels lampooned the activities of the Royal Society as completely working. Crazy stuff, he called it. And it's not that he didn't think that generating practical outcomes was a good thing, but he thought this was an undignified profession for people who call themselves philosophers. They should be engaged in much more dignified pursuits, and that these really were beneath, that the sorts of goals and things that they sought were really unworthy ones. And I guess, so the lesson is that there's a general lesson in history, I think, that the idea of history is another country. But you start to understand the relativities of the sets of values that you have, and they can be not necessarily overthrow them and say they're crazy. Well, the 17th century had it right and had it wrong. But at least you get a sense of the how certain things become trendy, and it leads you to question perhaps what the overall priorities might be. And we often, as I said, there are criticisms of science, but very often they're quite shallow, and I'm not advocating here that we critique science necessarily, but we do need to think about, we need to be self-conscious about what we're doing when we have these enormous investments in various things like $14 billion colliders. Right. Not that there's anything wrong with that, but just as curiosity versus charity. So that, I'll stop on that point before I get myself into deep trouble.
Thank you very much indeed.